Hi everyone, in this video I'm going to discuss about the Hall Effect Transducer, which is a very important topic for the competitive exam. If you find this video helpful, please like, share and subscribe to my channel for more education content. Let's get started. The Hall Effect element is a type of transducer which is used for measuring the magnetic field by converting it into an EMF. The direct measurement of the magnetic field is not possible. Thus the Hall Effect Transducer is used. The transducer converts the magnetic field into electrical quantity which is easily measured by analog to digital meters. Principle of Hall Effect Transducer. The principle of Hall Effect Transducer is that a current carrying strip of the conductor is placed in a transverse magnetic field, then the EMF develops on the edges of the conductor. The magnitude of the developed voltage depends upon the density of flux, and this property of the conductor is called the Hall effect. The Hall effect element is mainly used for magnetic measurement and for sensing the current. The metal and the semiconductor has the property of Hall effect, which depends upon the density and the mobility of electrons. Consider the Hall effect element shown in the figure below. The currents apply through the LEDs 1 and 2 and the output is obtained from the strip 3 and 4. And the 3 and 4 have same potential when no field is applied across the strip. When the magnetic field is applied to the strip, the output voltage develops across the output 3 and 4, and the developed output voltage is directly proportional to the strength of the material. The output voltage is given by EH is equal to KH divided by T, where KH is the Hall effect coefficient, T is thickness of strip, I is current, and B is magnetic density. The current and the magnetic field strength can be measured with the help of output voltage, and the Hall effect EMF is very small in conductor, because of which it is difficult to measure. But semiconductors like germanium produces large EMF which is easily measured by the moving coil instrument. Application of Hall effect transducer. The magnetic to electric transducer. The Hall effect element is used for converting the magnetic flux into electrical transducer. The magnetic field are measured by placing the semiconductor material in the measure's magnetic field. The output voltage develops at the end of the semiconductor strips, and this voltage is directly proportional to the magnetic field density. The Hall effect transducer requires small space and also gives the continuous signal and the magnetic field strength. The only disadvantage of the transducer is that it is highly sensitive to temperature, and thus calibration occurs in each cases. Measurement of displacement. The Hall effect element measures the displacement of any structural element. For example, consider the ferromagnetic structure which has a permanent magnet. The Hall effect transducer placed between the poles of the permanent magnet. The magnetic field strength across the Hall effect element changes by changing the position of the ferromagnetic field. Measurement of current. The Hall effect transducer is also used for measuring the current without any physical connection between the conductor, circuit and meter. The AC and DC is applied across the conductor for developing the magnetic field. The strength of the magnetic field is directly proportional to the applied current. The magnetic field develops the EMF across the strip, and this EMF depends upon the strength of the conductor. Measurement of power. The Hall effect transducer is used for measuring the power of the conductor. Current is applied across the conductor which develops the magnetic field. The intensity of the field depends upon the current. The magnetic field induces the voltage across the strip, and the output voltage of the multiplier is directly proportional to the power of the transducer. Thank you.